Hi, everybody. This is the Physics of Bitcoin show. I am here with Stephen Perrineau. I am the director of the Scientific Bitcoin Institute, and Stephen is the vice director. The show right now is I am in the headquarters of the Scientific Bitcoin Institute in Torino. I have a nice microphone, just got it. And today is episode 52.
Yes.
52. And that's August 6, 2006. 26. Okay. So it has been an intense few weeks. We had several things happening, but probably the most let's say, consequential event has been the cold card event. We have many videos that cover what happened. I'm planning anyway to make a separate video with a detailed analysis of what happened and what are the consequences, because actually almost everything that has to do with Bitcoin, you can find a physics connection. But this particular one is very much physics because in the end it has to do with the meaning of information, and physics as you can think about the entire universe as basically information. Like the ultimate substance of the universe is neither matter or energy, is information. How these matter and energy organize themselves and how they interact with other chunks of information or matter. And so information is a very important topic in physics. And also this idea that you still need the physical world to reproduce um, good information, or actually the lack of information, or scrambled information, whatever you want to call it, because that is the main topic, right? One of the topic was, so the hack, basically, to summarize for the people that maybe were under a rock and don't know what exactly happened. So the idea is that, and Stephen can correct me in this if I make any mistake, but basically, you can own your Bitcoin by having access to a key, right? It's a cryptographic key. There is an address that is public where people can send you Bitcoins, and then there is a private key that gives you access to that particular address, right? And that address is associated with owning a certain amount of Bitcoins. There is a lot of misunderstanding about that. I had to actually go back to the basics myself and even review some of these concepts, because I was exposed to it. But Bitcoin is so complex topic. It's beautiful and clean when you start to understand it in all these derivations, but there are a lot of steps, right? And anything that is complicated, it reduces to something simple when you break it down in steps. But so I had to go back and review some of the steps myself. But so many people think, because there are some misconceptions about this, right? That if you put, quote unquote, Bitcoins in a wallet, like a cold wallet, the Bitcoins are there, right? Physically. They are not. What you are doing, you are storing some information that gives you access to the Bitcoins, but the Bitcoins really live in the blockchain. It's a ledger. There is this ledger, imagine a big book, right? Where I have these addresses and associate a number of Bitcoin to that address. Some people, one particular person, maybe an institution, whatever, has access to that address and can move a Bitcoin. They can send it, they can receive or send Bitcoins. And the ledger, with certain particular rules, based on proof of work and whatever, updates this ledger, right? And it tells if something happens, like you're moving Bitcoin and send it to another address, that operation, the transactions is recorded, is verified, and then finally is transcribed in this ledger once and forever, and it doesn't change. So we all in the community, we often say, right, that the ultimate way of owning Bitcoin, because it gives you independence, it gives you control. You That is really the core and nature of Bitcoin, because there is no other monetary system that does it quite like Bitcoin. Yes, there are some other shit coins. They are trying to replicate what Bitcoin does, but they have their own problems and so on. There is only Bitcoin in that, right? That does it. Has Bitcoin does it, and also it has the power of this network that we are aware of, right? Um, and the way it does it, it has to follow certain particular rules, and you have to understand these rules, right? And and part of what you have to understand is that cryptographic key, uh, if you have control of that key, you have control of your bitcoins, and it doesn't matter how you do it. That is both the freedom that you have, because I can leave Italy, something happens to this country or Europe or whatever, I can go somewhere else in the world. If I have access to the internet, I can, even in theory without internet, but usually, to move the bitcoins around, you need the internet. I can revive my wallet using in theory is the key, but they simplified by breaking the key in chunks, and these chunks are represented by these words in what is called a passphrase, a seed passphrase. Uh, and that is the seed to reconstruct your key. Now, you can do it with 12 words, you can do it with 24. Of course, more words, more difficult is to recreate these words. And the idea is that in the past, in the beginning, probably the reason why it was done was, well, you're going to memorize some kind of sequence of words that are meaningful to you, and then that is enough to both remember it and also bring back the key, right? The problem with that is that people, when you give an opportunity, particularly if there is money. So when the network was small and Bitcoin was not worth much, and people had in mind mostly uh, testing it as a way of exchanging money, right? So when people were buying pizza for thousands of Bitcoin, it didn't really matter. You could have memorized a song or whatever, and you had access to your wallet. At most, you lost something on the order of few pizzas, right? So it was not a big deal. As Bitcoin started to become more and more valuable, and some of these wallets, some of these addresses contain equivalent of millions of dollars, doing it in that way by memorizing some song or some poem was a security risk. Because what happened, there are good people and bad people, and some of these bad people are very clever. They came up with many different attacks features, attacks venues, and one of them is to record literally the entire Bible, for example, because people like the Bible, so maybe they made a passphrase, a seed passphrase based on some verse of the Bible or songs or whatever. And many people, I don't know if you guys are aware of this, many people, it's not just a cold card problem. And this problem has been a real problem for for a long time. People have lost a lot of bitcoins simply because of a thought that this was a clever mnemonics. They memorize a song, but there are hackers that created database of songs, and then they try them. In particular, as computers are becoming more powerful, they can solve problems like these, like going through thousands or millions or even hundreds of millions or billions of combinations. Well, in particular, if there is a lot of information, that is a problem. This where I'm going with the entropy issue. If you have a meaningful sentence, it seems random to you, but it's not random. Like we just say, it's information. So I can find a source of information, like a database with all the songs in the world that they were ever composed. And you think, come on, how can they found this particular weird song that I like that is not even popular, it will be impossible, right? No, it's not impossible because I can go. There are lyrics website that list thousand, hundreds of thousands, maybe even millions of songs. I can download it. Then I can have a computer going through all these songs. And right now, computers are becoming more and more powerful. And if a motivation is big enough, I can go through all the songs that were ever composed in many different languages, and I can accure a password. And so, people started to avoid doing that. But, memorizing 24 words is not easy. So they had basically wallets to memorize, to have these. So you can click some buttons, etc. There is the passphrase there, but it went in where people started to trust more and more this technology device, these wallets, these cold wallets, um, that are pieces of electronics that basically they generate this phrase, but by trying to make it as random as possible, and we can discuss that in a second how we do that, and then um, relying on the electronics to store this information. That is the problem. They store the information. So if you have access to that piece of electronics, that you can put in a safe, etc. People in the old time say, write it down in a piece of paper. Believe it or not, as so Bitcoin is a very technological thing, very powerful technological thing, but sometimes security is based on very simple low-tech things like writing the seed phrase on a piece of paper, because that is really safe, because it cannot be, even if you don't connect the device to the internet, um, a piece of paper is even less connected to the internet, there is still a way of doing things, of course people can get hold of your piece of paper, okay, but it's still, even if you memorize it, they can hold of you and put the gun on your head. Nothing is ever 100% safe, right? We are trying to minimize the problems and the mistakes and so on. That is the entire thing. And within reason, you can take actions to make it as safe as possible. In this case, what happened is that the machine that people trusted to do some of these steps, like randomizing the words. And so what is the idea of randomizing the word, right? So basically, because you have 24 words, imagine all the possible way you can combine these words, right? And the order also matters, right? So it's not just 24 words in a hat, it's how the sequence itself. So that creates even more randomization, right? Because there are so many ways of organizing 24 words in a particular sequence. They can repeat themselves, it doesn't matter. If you have in fact, actually, by having words that repeat itself, you make it even more random because you make the set larger. Otherwise, you restrict it. Every time you restrict this set of 24 words combination, you make the set smaller. In this case, what happened is that there was a bug in the code that was not caught for 5 years that forced the system to go to kind of a default thing, to go to a set that was much smaller. Basically, because everything is in base 2, because we are talking about information. Information is on and off, right? You can encode information using bits, that is basically 0 and 1s. So you can do it in many other ways, but 0, 1 is useful and used by electronic devices because basically you can have a piece of electronics that is on and off, and these two states can represent information, right? And then you have many of these states that basically can represent anything, images, words, concept, operations, all kind of things like that. So more often when we talk about information, we represent it in base 2. And so the number of combinations available to this machine was 2 to the 40. That sounds an incredible number. So basically means, what does it mean 2 to the 40? It means that you take 2 and multiply it by 2, and you multiply by 2, and you multiply by 2 40 times. So it seems an enormous number. Well, if you translate it in the other scientific notation, that is base 10, that is more familiar because, 10 to the 2 is 100, 10 to the 3, 1,000, 10 to the 6, a million, 10 to the 9, a billion, and so on. Actually, with 2 to the 40 turns out to be on the order of trillions, okay? And trillion sounds an enormous number, but for modern computer is nothing. You can look at trillions of combination within minutes, if not at most 1 hour. In fact, I think the hack happened within an hour, right? It continues, but within an hour, they almost exhausted the entire space of these 240 combinations.
So I want to comment. One thing that's quite important about this hack is they had the hardware in there for random number generation, but they introduced a bug in the code and they didn't use the hardware. The hardware would have given them 256 bits, but instead they used a software routine, and I don't know why. It's really strange, but it only had 40 bits accuracy in that software routine. So they had, within their chip, they had the RNG, the random number generator, but they weren't using it.
Yeah, because basically there was a bug that when they were trying to compile the code, because I saw some posts that mentioned this, the compiling means basically you write it in human form, and then the algorithm write it in a form that the computer can understand, basically in this 0-1 language. And that process was not working because there was some bug in the code that actually should have been taken seriously by the coder, saying, well, something is wrong here, let me find the cause, even if it's going to take me a long time because of these bugs. Now with AI, and that is the problem, they found the bug, the hackers found the bug and exploited it because they use AI. And for AI, reading these codes is almost like a play, children play. They are machines trying to understand machines, and the code is very systematic, and they are extremely good in that, in both creating amazing code, but also finding human errors like this. And so they reported it to the hacker. Probably did it with some Chinese AI that if you try to do it with that is actually a problem, because if you try to do it with a Western AI, the AI will tell you, I'm not going to do it because you're going to exploit this. But actually, it's a problem if I want to try to find out if there is a bug, And so helping to find the bug that, and then I can fix it. If it is something concerning security, the AI will start to complain that you have probably to prompt it correctly, but yeah, it's another completely different issue. But anyway, so the problem is that they didn't do the proper thing and say, well, let's fix the bug and find out what is wrong. They say, well, okay, there is this bug, forget about it. Kind of almost like that. They say, okay, if it fails, go to parameter equals 0. That meant basically bypass this creation of more random type of combination and go to the default one. And the default one was completely not adequate for the task. I added too little randomization. That sounds still amazing, a trillion combination, but it's nothing for a modern computer. And so whoever found the bug, these hackers, probably they were looking, given what AI is giving us, it is. When I grew up, I never thought, I knew that AI could be used for bad things. I never liked Terminator scenarios, etc. I think AI has more positive things than negative things. I think Terminator scenarios are not going to happen ever. But I saw 2001 and AI is killing people, because they think they want to do a good thing or whatever, and then they don't know, they don't have good sense enough or whatever. But I never thought about hacking, that they could be a problem with hacking, and they are so good in hacking because we understand code, right? So you can make it run through many different applications, different things that we use all the time. And this is why, for example, for some time, Fable was not allowed to be distributed to the public because they were using it to find so many different hacks in many different systems that it was considered almost like a national security problem. I guess they found all these possible hacks, or a lot of them, and they fixed them, and then they released it. Probably also with some some guards on how you can use it. So, and in theory, you cannot use it for exploits like this. But when there are these Chinese form of AI that you can run on your computer locally, and it will do whatever you want. If you tell it hack something, it will hack something. We don't have all these safeguards that our Western AIs have, and so they found this vulnerability, and they were able to recreate these supposedly very random words. And we went through all the space of possibilities. Now, what is the solution? Well, people have come up with many different solutions. They say, okay, use this, use it. I don't like at all let's go all the way to the extreme other solutions. So let's not do cold storage anymore. This cold storage is dead. That is absurd because the core property of Bitcoin is exactly that possibility. And the beauty of Bitcoin is that it gives you a range of possible ways you can interact with Bitcoin. Okay. When the ETFs came out, I was one of the people that say it's a good thing because you know what? There will be some people like the pensioner, doesn't want to know about new technology, etc., that sees that this thing is traded by BlackRock. They know what BlackRock is, or maybe their financial advisor knows what BlackRock is, and they are going to propose them, oh, let's try this thing, or maybe they have authority to put a little bit of IBIT in the portfolio, even without the person knowing, because it's a pension fund or whatever. And it is going to give exposure to Bitcoin to people that would never have Bitcoin exposure if it went ahead and had to buy Bitcoin from an exchange and do cold storage or whatever. So the beauty is that you can have that all the way to people that study every detail of how Bitcoin work. They understand proof of work. They understand all the details of Merkle trees or whatever, So that is the beauty of Bitcoin. It gives you all this range of how you can interact with the system. And cold storage is not dead. It's as good as it was, has always been. You have just now to understand that if you really, 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 really want to be safe, then you have to take certain steps. It turns out that even with what Stephen was saying, for example, you could use, okay, let me say this. We know that computers, if you have a minimum knowledge of computers, I use it all the time, right? They can create random numbers. Me and Stephen, sometimes, for example, to test, right now we are testing these log periodic models, right? We need to test to see if you can get log periodicity by chance. And so you ask the computer to create random histories of Bitcoin that maybe can reproduce that log periodicity. And then you compare what you get by these random histories with the real signal that we observe and say, can this signal can be reproduced by noise, for example, by fake randomness, right? From randomness, let's say. And the computers for tasks like that does a pretty good job, okay? And but the computer by algorithm, by definition almost, an algorithm is a deterministic process. It means step by step, every step, we know exactly what we are doing. And this topic of randomness is a very fascinating topic. We still don't understand what randomness. In a sense, I don't think probably, beside quantum randomness, that is its own thing that we understand even less, and probably something very fundamental about the nature of the universe. Normal randomness, and most people deal, that is classical randomness, is basically somebody else's information. Like, for example, when I was studying neuroscience, the brain produced so much stuff, and it's all usually most of it is stuff that does something. But if you are interested in a particular phenomena, let's say, for example, I was studying slow waves, particular signals in the brain during sleep, that is my signal, and everything else is noise, even if that noise is actually something that the brain needs to do because it's doing other operations, right? So what I want to say, for example, imagine you have a bunch of balls that represent atoms moving in a box, right? All these motions are deterministic because they go from A to B in a very precise way. They follow the laws of physics, etc. But there is so many of them that I cannot keep track. So it's not that they are doing completely um, I don't want to use the word random, completely unknown things. In theory, if you have a box, you can zoom in, you can see every single particle, and you can keep track of everything. But we usually don't have access to that, right? And even if we had access, uh, keeping track of all this information and describing it, etc., is not even worth it. So you end up with giving some kind of an average measurement of a behavior of these particles, right? And that is when we use this word randomness. It's a random process. If I look at the velocity, for example, of this particle, they're going to have a distribution. Some of them are very fast, some of them are very slow, and they are going to have some kind of distribution that is usually a bell curve, where an average of the particles have a certain value, and there are very few that are very fast, very few that are very slow, right? That is the intuitive understanding of randomness. Um, and so in this case, because randomness sometimes is your enemy because you call it noise, because maybe you are looking for a particular signal and the noise is covering your signal, so you have to extract it from a signal. In this case, it's our friend. We want as much noise as possible because we want to have some kind of, we want to hide the information that is the that is the key, and we want to hide it in something that is so vast in terms of possibilities, right? All this possibility, and that the noise help us to hide. We are hiding inside noise, and so we want as much noise as possible, right? We want as much as randomness as possible, and computers are not very good in creating that randomness through an algorithm. That is the idea. If you have an algorithm, you're following a process that is step by step, and you can simulate, right? There is an entire field that is trying to find a way of using a deterministic process to create something that looks like noise, but in the end is not really noise. It's still a lot of maybe complicated information, but is information. So if I know how I started, what was the seed of a randomness, the starting point of a randomness, I can recreate that randomness almost step by step. It's almost like, imagine I do a simulation of all these balls and I know where the ball started and the initial conditions, so the initial directions of the balls, and I can have a million of them. I can recreate the entire history. Okay, so that is what we are dealing with now. The way to overcome that problem with computer in faking randomness is to use some kind of a process that is still not accessible to us, because we don't know how to keep track of a million or billion or trillion particles inside a hot box, right? Hot air, hot liquid, or whatever it is. Um, we don't have a technology. Maybe one day we will have a way of tracking the position of all these particles or whatever, but now we don't. Right? So physical randomness is still, believe it or not, the best way to get randomness. Okay, going back to the word and say, hey, make randomness for me instead of relying on a computer. And Stephen was mentioning the randomness that you can get from the device. What will it be? Well, if you have a camera, you can use the pixels in the camera, right? We have sensors, light sensors that are basically always, think about this. This is, again, if you are not a scientist, sorry if I take all these things, but it's most of physical physics. I know it's a bad situation, but it's one of the situations where being a physicist give you insight that maybe other people don't do. So I'm trying to share these insights, right? But usually what happens, most of the way we learn from the world, we do it by translating some kind of a signal. For example, imagine I have a light, right, that the camera is trying to sense. I have this device that detect the light through some process. Then they translate that light into electrical signals. It's always like this. When I was measuring information from the brain, we were taking that case is electricity to electricity, but because it's electrical impulses. But imagine I'm looking for I'm measuring temperature. I am measuring temperature. The temperature is some kind of information, average velocity of a particle inside the water or whatever, measuring the temperature of, and then I transform that into electricity, right? So in doing this transformation, you can introduce noise because with every device, when records electricity as interference, there is interference from the environment because there are many form of like wire, for example, in a room, they produce noise. And if you are recording with your device, you can be affected by this environment information. But also there is some internal processes, quantum mechanical process called shot noise that the device produce by themselves. It's like almost like kind of fluctuations that are happening spontaneously all the time inside the device. So you could use that as your source of randomness, right? And some of these devices do that, right? Use the internal noise of a device and maybe even external sources to create randomness, physical randomness. I was discussing with Stephen just before that. The problem with this is that you need still a piece of code that take that randomness, physical randomness, that is better than the randomness created by these pseudo-random attempts of the computers to create randomness. In this case, use a real physical randomness that is still difficult for us to hold or understand. And then, in particular, quantum one, that is even more mysterious and more random than classical processes. And then you need to translate it, right? You need to translate it in, because remember, the goal is to go from this randomness to 24 words, right? You need still some code that does this transformation. And so you will have to rely the company to do a good job in doing that, okay? Yes, the intention is good. They are using something that is innate, random, but how they do it, right? Do you trust the company? That is the problem, right? Do you trust the company that made the device? Now, if you go back to basic and also this process, right? Shot noise, what the heck? Do I understand what shot noise is? You know, a physicist understands it, but what about the average person, right? So there are ways of dealing with this. This is why we insisted in my account, for example, I talk about something that sounds silly to many people because you're thinking Bitcoin is this advanced technology, etc. Do you mean I need to use something as simple as, remember every time when we were talking about writing your seed phrase on a piece of paper? That is so simple technology. Or you go to conferences and they tell you to stamp it on a piece of aluminum or whatever, you know. It's relatively simple technology, but it works. If it works, it's fine. So one of the simplest technology to create randomness is to throw dice. Because I play these board games like Warhammer, for example, and we know very well by experience that actually it's a good way of creating randomness. You could use a phone and create some random numbers and pretend you're rolling dice electronically, but we don't do it because exactly what I described. All this, it's still fake randomness with launching dice. With what is happening? Your dice, it's a physical object how you throw it is never reproducible. Even, there are people that go to casinos and learn how to throw dice in a certain way because they say they can push it in a certain way and make certain numbers roll. But even after years of training, it's very difficult because it's very difficult to reproduce it. Remember, you're not trying to do that. You're trying to do the opposite. So you're probably going to do it in a way that is different every time. You can change your hands. You can launch the dice in a strange way, very strongly. You can shake it in a container, and then it's almost impossible not to get randomness in that way. And you throw it and you do it 11 times. You can better, it will be better because then are independent dice. So if you have 99 dice, and believe me, 99 dice, there are dice that are also small. If you want, the casino ones are big. But I rolled myself hundreds of dice, in some of these games. And it's not that difficult. You can put them in a container, you can shake them and throw them. Or if you don't want the 99 dice, you can take 9 dice and do it 11 times, or maybe 11 dice and do it 9 times. And then you have 99 dice. And 99 dice is because if you go through the math of 99, is basically you get the randomness that is suggested, that is 256, right? 2 to the 256, and that gives you 10 to the 1077. So combination, 10 to the 77 combination means 10 with 77 zeros, okay? There are about 10 to the 80 atoms in the universe. So that is 1,000. So it's a small fraction, but all the atoms in the universe. So imagine, you take 1,000 of the size of the universe, it's still amazingly
The
big.
visible universe.
Yeah, the visible universe. And then you have a passphrase that is one of the atoms. So imagine somebody wanted to hack your wallet, he needs to go to in this enormous quantity of atoms. It's about something on the order of 2 billion galaxies, and need to pick that single atom. Okay, it's basically impossible. So what will happen is that hackers will not even try because they don't have a motivation to do it. They will say, well, this is basically an impossible task. They can try. I can try to win the lottery. Here at the institute, we have one of these solo miners. We run it just for fun, and to support is supporting the network anyway, because it's kind of a node in doing that. But the chances of winning are so small. This what we are describing, people don't still realize. Imagine, I don't know if you understand how many atoms there are in anything, even a small grain of sand. There are enormous quantity. What it is, 10 to the minus 20.
Well,
An atom is
Avogadro's number is 6 times 10 to the 23rd.
third, right? 23,
Yeah.
right? So, and that is what, like 1 gram of stuff about.
Well, it's like if it's oxygen, it's 18 grams of
Yeah,
oxygen.
on the order of a few grams of stuff, right? So a few grams of stuff.
It's water. It's 18 grams of water. Yeah.
Yeah. So it's so a few grams of stuff already contains 10 to the 23 atoms, and 23 is what 10 to the 18 will be
Well, it's
billion,
almost a
it's
trillion
10,000 billions, okay, of atoms. And we are talking about something that is, and this is why when we tell you that understanding the order of magnitude is a way to understand Bitcoin, because it comes up in the power law, but it comes up in stuff like that too. So order of magnitude to understand should be something that every single person on earth understand, because it gives you a way of understanding the universe, right? And so in 10 to the 7th is unimaginable, even for a physicist. I mean, I can pretend to understand it. I don't understand it. It's so, there is not an intuitive understanding or something like that. The math is simple. You write 10 to the 77. This is why we like the scientific notation. You can represent it, but having even a grasp, even if I tell you all the atoms in, what does it mean? Then it's like something impossible. And you can create these with dice, okay? So I will not understand why people will not take the time If you think it's nerdy, do it alone in a room. Say, I will never do it. I mean, do it. Nobody knows. Don't, if you don't want even your wife to know it, that you roll dice. Hey, that guy roll dice. Look at how weird he is. It's silly. It's something that will assure enough randomness so it's your wallet is safe. Now, you will have to go from the roll. That the beauty of the rolls, you can see them. Okay, you can do it with your hands. You are in control of this process, and now it's a question of taking these 99 numbers that you can write on a piece of paper, then burn the piece of paper, destroy it, throw it in the toilet, whatever you like, uh, and put it, because there are tables and there are processes. In fact, I will add these to the website. So the Scientific Bitcoin Institute wants to do, among the other things, to be some kind of resource for the community. So you can come to our website. We had a discussion yesterday with the board about what do we do about this, because I know many people are turned out by experts giving their opinion about this or that, right? It's no opinion, it's knowledge. But I know that we had some bad experiences with COVID, etc. So it's much better, I think, for a group of knowledgeable people to give and share their knowledge and give definition, information. Hopefully, I took a lot of time, but maybe you learned something from all this discussion. And then with this information, you decide what to do. So the Institute will try to respond to different crises. Bitcoin has crisis is part of what Bitcoin is. We will continue to have crises and survive them and become stronger with time. But information is very important. So we will try to create resources, information, and then people can do, right? We're not going to tell you, do the dice. I can do it as a Giovanni. I think it's a good idea, but this institute will give you information, we will give you the tool, and then you decide what to do with them, okay? But at least you have a place where you have people that know this, understand these topics, like me, Stephen, etc., and other people that are joining the institute. Maybe we could bring real security experts and they will give you the information. Then you have information there and you have some tools. So one of the tools I created, because I couldn't sleep. I was not involved. I got hacked 35 Bitcoins on an exchange years ago in 2014. So I know exactly how it feels to have a kind of theft. And believe me, even if it was several years ago, when I bought Bitcoin, I knew that Bitcoin was going to $1 million. In my mind, I never doubted that. So I lost $35 million at a minimum. At that time, it felt in that way. I didn't feel like, oh, these Bitcoins are worth less. In my mind, we're worth at least $1 million, if not more, infinite. Because in a sense, Bitcoin are infinite value. So it was really like they took a piece of me, of my soul, okay? I understand it. I empathize completely with the people that went through this. And I couldn't sleep. And then I thought, well, as an institute, scientific institute, we need to respond somehow and made this tool, right? So hopefully it's a useful tool. And let me show you a little bit what it does. So maybe it's useful to you. Again, you don't want to do it. That is the beauty of Bitcoin. You don't have to do it, okay? If you want to do it, then it's there available to you, okay? Let me, and you want to add, while I'm doing this, you want to add something, Stephen, or maybe you have some insights about all these that are better than mine.
Yeah. Well, I think if you want to rely on a hardware wallet, go look and see what they're using, because the ones that are better use multiple noise sources and combine those. So that's going to increase the difficulty. They're going to go through algorithms, right? So there's still going to be software involved, and that's where the danger occurs. If you want to use external noise, physical noise, then either buy a bunch of Geiger counters or find a way to generate a couple of thousand neutrons all at the same time and watch them decay. And that's not practical. So the next best thing to do is to use dice.
Yeah.
and it's better than cards because it's very hard to shuffle cards properly. So really, dice works very, very well, and it will get you, that 256-bit hardness.
Yeah. So, and we did this as an institute. We did this tool again. Hopefully, something that at least some people find it useful. It's fair. You can use it, not use it. It's up to you. But what it does, first of all, the idea is you can download it. So don't use it online. You can use it online to learn how it works, just as a demonstration. But it's meant to be downloaded. And in fact, it has, when you download it, you open it, it has a tab that tells you you are online, because that is another security risk. Turn off your internet, okay? Turn off your any connections you have. You can go on your computer, you can turn it off, you can turn off the Wi-Fi. Don't do it on your phone, because that is another place where it's relatively easy to hack, because they are more connected anyway. You could maybe do it in airplane mode, but I don't suggest you to do that. Just use a laptop, maybe even an old laptop or whatever. So download it, turn it off from the internet, and then use the tool. Now, the beauty of a tool, it has two different ways. It uses Python. So if you, I don't know Python, well, take the code and give it to ChatGPT. Tell it, do you see any problem with this? Do you see any bug with this? It's a relatively simple code. It does only one thing. It takes your 99 roles and it transforms it in a seed phrase. And it's a very simple code, very straightforward. Copy it. It's open access. You can take, there is an HTML code and a Python code, and the app is meant to combine the two and make sure that they give you the same result. It's another safety check, right? Okay. And then take both code, give it to ChatGPT, one give it to Claude, and see what if I think there is a bug. There is not a bug. I double check it, triple check it. It should not have a bug, but give it to that and see if there is an error, and tells you what it does. What it does is simply a very simple algorithm to go from the roles to the phrase. Okay. So, and if you feel safe, if you think, double check, verify everything, triple verify, quadruple verify, and if it is something that you find useful, then you are in control of everything. You know the algo, you know it works, you double check it, you created the randomness yourself. Last step is simply to put these 99 values, make sure you're in a closed room, maybe even lock it, close the windows, everything. Of course, it depends. If you're trying to do it with $10, I don't know if you want to go all that. If you have life savings in Bitcoin, then take all these precautions. Okay, you have to do it once, and I don't understand why you will not do this to secure your future. Okay, so do all these precautions, create your pass phrase. Now, where you store it, I think a piece of paper probably is the best way. You can memorize it. I can memorize easily 100 words because I train myself. There are mnemonic approaches, etc. You can use a piece of paper, store it in a safe. It's a problem, or you can use one of these wallets that allow you actually to put your own randomization. They allow you to do that. Even the cold card, if you wanted to use the dice, you could have done that. The problem is the step of going from the dice to the words was done internally, and I don't know if I wanted to trust cold card in doing that either. We did it, okay? And the beauty is that you have access to the code. It's an independent code. You can double check it with AI. So you can do this step yourself. And you don't need any wallet if you wanted to do it with a paper wallet, okay? So it's a tool. We wanted to respond with doing something useful, and hopefully in the future, as we grow, we'll give other resources. We don't want to opinionate. I like this approach. One of us, Pius, in fact, he We say, let's not come up with, oh, you should do that, because basically I saw too many people online in the last few days say, oh, go to ATF. Everybody that doesn't do ATF is stupid. No, we are not going to say that. Okay. I think knowledge is always something that is so powerful. When once you acquire it, then it tells you what to do, right? So if you understand this topic and you go deep, try to learn. The beauty with Bitcoin is that you learn a lot of things that maybe you didn't need to learn in the past. Who cares what entropy is? I think everybody should know what entropy, because it's so important in understanding the universe in general. But with Bitcoin, it becomes an important thing, a life and death situation sometimes, right? To learn all this topic. I started to study economy and other topic that I will never have studied before if it was not for Bitcoin. So that is the beauty. You learn something, and then based on that knowledge, you take your decision, what you want to do, right? I'm going to add to this also a kind of a review. I saw a few nice ones about different cold wallet, which one. There was somebody, I'm going to give you credit, they made like almost a table of all what is available, what are the strengths, what are the weaknesses, how they do it. So it's another resource, okay? So think about the Institute as creating resources for the community. We are a non-profit. We want to be useful, okay? And give us some feedback on what we can do to help more if we can. Anyway, Stephen, do you have any more comments about this?
No, no more comments on that. This word entropy is confusing to people. Entropy means how many numbers would you need to recreate something? When the universe was created, it had almost no entropy. We see this when we look at the cosmic microwave background. It's highly uniform.
Mhm.
It's just this uniform gas that only had a few different kinds of particles in it. There was almost no density variation, almost no temperature variation. You can therefore describe it very simply, even though it's that 10 to the 80 atoms, right? You can define it very simply. And when we talk about the temperature in the room, we're kind of saying, okay, the room is more or less at uniform temperature, and it goes through this quote unquote randomization process to smooth everything out. And so if you can use just a few numbers to describe something accurately, that's low entropy. We want high entropy.
It's
So
the
all of
opposite of entropy is information, right? High information, low entropy, and vice versa. So
yeah.
information is, if I tell you my street, if I tell you where the institute is, right? It's Via Pietro Micca 21, Torino, Italy. I gave you few pieces of information that describe perfectly where I am located. Okay, maybe the floor. You don't know the floor. I can tell you. Okay, I'm on the second floor, so you can come and visit me. Right, visit the institute or whatever. That is information. It's a few pieces of numbers. Right, you can actually translate it exactly in numbers, like my coordinates. Right, two numbers can give you my coordinates. Two numbers are enough because we live on a surface, right? Two numbers are enough to identify my position. That is information. The opposite, right? If I wanted to hide myself, I will try to find a number of possible combinations of where I could be that is so big that you will never find me, right? And that is the idea behind these things. I will create a space. I will mix up. Instead of using two coordinates, I will use 24 coordinates. It will matter the sequence of the coordinates. I will make it so complicated, and then I will not tell you where I am. I say, okay, now guess where I am, right? That is the entire idea.
It'll be like a treasure map, these pirate treasure maps, right?
Exactly, right?
You have many steps you have to go through.
Yeah, where am I? And you have to find. And now, if you think that finding a treasure, in all, imagine digging randomly in the world and finding a treasure. That task, I'm telling you, it's easier than what we are describing here, because I think actually probably one could calculate, right, how long it will take to test enough of a space around the Earth. Actually, I will try to do it. Like imagine you have every second you can test some spot in on Earth, right? And I don't know, you do it with a machine or whatever. Imagine it's a surface, uniform surface. There are, and actually, in fact, if you start to eliminate the continent, but it, in the end, it doesn't matter. That is another thing that many people don't get it. Imagine the surface of the Earth is half water. You say, well, I'm not going. You can find treasure in the bottom of oceans, but let's say we eliminate all the water, right? And imagine the water is only 50%. I don't know what it is. Maybe it's more than 50%, but roughly 50%, right? Where is 50% water, 50% Earth. And they say, hey, it's much easier because I'm going to focus only on the surface of the Earth. You know what? It doesn't matter. That is one of these things that we are trying also to teach people. You know why? Because when you're talking about order of magnitude things, it doesn't matter if you add or subtract a factor of 2 or 3 or 4, okay? So when people say, oh, try multisig, it doesn't really resolve the problem of entropy. Because if I have 3 ways of doing the same thing and I do it with 2 to the 40 combination, it's still 2 to the 40. They're adding 3 different ways of doing it, it doesn't change anything because we are talking about order of magnitude, right? We are talking about how many zeros we are dealing with. So if you multiply by 2 or 3, you're not changing the number of zeros. You want to change, and you don't want to change the number of 0 by 1 0. You want to change it by many, many, many zeros. So it doesn't matter if you change things by a factor of 2. So the multisig, okay, it's an additional security, but people can be confused by that too. They say, oh, I have 3 different ways of doing this. Well, if all 3 of them are small entropy, low entropy, you don't resolve by multisig. You don't resolve it at all because I can do it. I can hack all 3 of them, okay, very easily. Like it doesn't matter, okay. So that is one of the things that people really need to understand and learning new things, how to think in order of magnitude. We try that with the power law many times when we tell you, look, a 50% change in price is nothing when you're dealing with a process that is order of magnitude, okay? But in this case,
good segue into my slides.
Right?
That's a good segue into my slides.
Yeah, okay. So, okay, guys. And if we don't answer immediately your question, I already see one good question, but it's I kind of answer that question. All the sources of noise needs to have high entropy because it doesn't matter. Yeah, I mean, it solves all the problem. Multisig solves all the problem. Like it's nice that you do things in different ways, but it doesn't solve this low entropy problem. Okay, all of them need to have high entropy. Now, what it could solve is, but maybe there is a bug like this in one of them that gives you low entropy, but the other ones have a high entropy. In that case, yes, because maybe there is a mode of failure of one of these methods that gives you low entropy, but the other ones have it, and so you're safe. That is good. But if all 3 have low entropy, having more than one, it doesn't help. So yeah, that kind of answers your question. But in general, we answer questions. I need probably remind this all the time at the end of the show. At the end of the show, we go through all your questions and then we answer. Anyway, Stephen, I think we covered this long enough. Go to the website. There is a very long guide. I will add more material. I will add more references and more information. So please look at our site on a regular basis because we are going to try to be useful to the community with all this information. Okay, Stephen, are you ready for your presentation?
I'm ready. Can you see those?
Yeah.
Okay. Normally we're on Wednesdays, but we rescheduled to Thursdays. And we're going to actually introduce a second show after I finish Giovanni will talk about that, and that one will be on Thursdays around the same time, and this one will normally be on Wednesdays at 3:30 Central European time in the afternoon. And the agenda here is to show comparison to a number of different fiats, and that they are all power laws, and that there really is very little difference. You know, you put them on a long-term log chart, 6 lines look almost parallel. And the important thing is to look at them in both directions. Watch fiat going down as well, because then it's really striking. I'm going to answer the objection about inflation that always gets raised. Well, aren't you just seeing inflation reflected in the Bitcoin price? It's kind of, you know, one of these order of magnitude problems. If you thought about the order of magnitude at all, you'd realize, no, it's a tiny thing. It's epsilon compared to what's really going on. So I will address that one. And then I will show Bitcoin with respect to gold and 3 other commodities. And of course, they're all power laws. And I'll mention when Bitcoin may equal all gold on the above ground on the planet, and show a histogram of how stable these exponents are across them with these 10 different power laws that I'll show here. Okay, now there's prior work here. It's in the Physics of Bitcoin. So if you haven't read it, go look at chapter 7, and Giovanni demonstrates the power law against the euro, the yen, and the Australian dollar, also against gold and oil, and additionally against stocks with the S&P and real estate. I will not talk about stocks and real estate today, but they're all quite similar power laws. They all are the age of Bitcoin raised to some power greater than 5, you know, and within that range of 5 to 6. Okay, so here are the top 6 fiats. These are the most important fiats in the world. And that's the dollar, the euro, the yen, the Chinese yuan, the British pound. And then the last one is the IMF basket, the SDR, that is a weighted mix of those other 5. And, you know, you can look at other ones. You can look at Swiss franc, or you can look at the Canadian dollar and Australian dollar, but you're not going to see things very different unless it's a weak currency. But if it's one of the larger currencies, they're going to look quite similar. This extends for all 6 of these over roughly a factor of 1,000,000 increase in price for Bitcoin measured in those units, whether they be dollars or yuan. The dollar line here is in blue, and it's down there in the mix where the euro and the pound and the dollar are close to each other. And then 2 that stand out are the yuan and the yen, because, you know, it takes 150 something yen or 160 yen to the dollar, and 7 or 8 yuan to the dollar, so that they sort of stand out. But they all look quite similar and almost parallel. And they all have exponents in the range of 5.54 to 5.96. They all have very high R-squared fits with 0.96. And they all have very similar standard deviations. So if you just assume Gaussian, which is not really correct, but just as a first order characterization, they're all about 0.3, 0.29 to 0.31 in log 10 price terms, in DEX as we call it. And that's basically a factor of 2 in linear terms. So you move up or down a factor of 2, you know, that's only 2/3 of your data. You'd expect 1/3 to be even outside of that range. And then the table shows all the details, including the R-squared number. But now let's run the regression the other way. Flip the numerator and the denominator. So before we had Bitcoin over the dollar, now we have what's the dollar worth in Bitcoin terms, and you get a power law with a negative exponent. So it's the same value, but a negative exponent. So again, they all have R-squared of 0.96. All the exponents are in the range minus 5.5 to 6. I use monthly data here because that was the easy way to get all the exchange rates. And I could actually do this. I didn't even have to download to my machine. I could do this directly in ChatGPT and its environment. And again, we see the strongest is the British pound, the weakest is the yen. But you see basically fiat dropping by a factor of 1 million in price if you use Bitcoin as the denominator. Okay, so what about inflation? So here, the blue line is what you usually see when we do a log plot of Bitcoin price versus the dollar. And I've shown some linear ages down there, but that's a log axis for both the X and the Y axis. And I'm just showing, the doubles, 2, 4, 8, 16 for age. So we see the usual thing. The exponent here at 5.63 is slightly lower because of the monthly data, but nothing too material. But then the orange line, I've adjusted for the US dollar money supply, the M2 money supply over the history. And so that does change the slope a little bit, 5.16. But the R squared is still quite high, slightly lower. So it's not quite as good a fit, but it's still a very good fit. And you can do various things. You can look at market cap, with and without the M2 adjustment. And the thing to note here is that, yes, there's inflation in the dollar supply, but there's also been inflation in Bitcoin. And in fact, until age 7.5 at the second halving, the Bitcoin supply inflation was running higher than the US dollar M2 inflation. So the difference in the slope on this chart is only 9%, but this only corrects for one inflation. It corrects for the US dollar money supply inflation, but not for the Bitcoin supply inflation. And if you approximate both of those as power laws, which they're not, they're both more exponential, but roughly to just get the order of magnitude, they're almost comparable. And they tend to cancel each other out, at least over the history. And so the difference in exponent drops to be much less, only about 2% once you consider both inflations. And this just shows it for Bitcoin market cap, the green line. So you see a 6.2 exponent there, again, a very high R squared, or the M2 adjusted market cap. And if you look at these four, you can figure out that how much, roughly the inflation is adding or subtracting to the slope. And that's shown on the next slide. So if you take the M2 adjusted market cap, that slope is 5.75. So I have beta M2 adjusted market cap for the first bullet element, and then the equation in the second one, which is a compound of the normal price regression, which is a 5.63 slope, and the increase in Bitcoin supply pushes the slope up by 0.59, but the M2 drops it by 0.47. So those two almost cancel. And you just get the difference between 5.63 and 5.75. It's only a 2% difference in the slope when you net out both inflations. So basically, the general argument is that Bitcoin's price followed a power law despite quite rapid early supply inflation, during the first 7.5, 8 years. And overall, the two nearly cancel. So the scaling is the extraordinary growth in Bitcoin. It's not due to the M2 money supply inflation. It's not due to the increasing number of Bitcoin that were minted to the Bitcoin supply inflation. It's due to the network, the aggregate demand, which grew as basically a cube of Bitcoin's age. And then the squaring of that almost, which is the network value. So it's due to those two compound factors, viral adoption, cubic law, Metcalfe's law, a square law, and it turns out to be slightly less, 1.84. And of course, when you do this, this immediately obviates the stock to flow because we established price age scaling even when Bitcoin supply inflation was running at a high number and S2F was at a low number. Okay, and then when you go to commodities, I picked as major commodities gold, which is the blue line, silver, which is the orange line. WTI is oil, the West Texas Intermediate, and then corn is the red line. They're nicely spaced because these are defined by whatever the commodity units are, barrels of oil and ounces of gold and so forth, bushels of corn. They all have R squared, as we saw before, 0.95 to 0.97, very similar exponents in the range, basically 5.4 to 5.8. And their sigmas, their standard deviations in DEX terms, log 10 price terms, are also 0.3. And that's because Bitcoin's in the driving seat for all of these things here. And that's a factor of 2 in linear again. The strongest is gold, not surprisingly, and the weakest is oil. And this is just looking at it in the other direction, the fall of those commodity prices in Bitcoin terms. And this applies to stocks and it applies to real estate in rather similar indices if you go look in chapter 7 of the physics of Bitcoin. And then you can ask, all right, can we extrapolate when Bitcoin could match all of the gold? There's about 6.5 billion ounces of gold above ground, and we're a little above 4,000. So that tells you, you need to get close to 30 trillion for the market cap of Bitcoin. When you work it out purely in gold terms, because that's how the regression was performed, you need to get to 365 ounces. And that's allowing for some increase between now and then of the amount of gold, which is increasing by something less than 2% per year, but I use 2%. So in the future, it'll be more like 7 billion ounces, in the next decade. And the crossover on trend looks like the beginning of 2033. Now, we're well below trend right now. And on this chart, on the blue line, you see that the dots are at the far right have pushed up above the line. So gold has been outperforming quite a bit in the last year, especially. If we were on trend, we'd be at 68 ounces. So we would be about a factor of 4 higher than we are today. So that's a kind of a 2 sigma excursion, which you do expect to happen, from time to time. It's one-sided, it's 2.5%, two-sided, it's 5% kind of event. So in order to get to this 365 ounces by, say, the beginning of 2033, we've got to make up that ground, get back to trend, and then continue on trend. And so this is what it looks like if you plot in the other direction. Gold ounces per Bitcoin, 360 ounces, age 24. That's the beginning of 2033. Power law index 5.38, R squared 0.95. So we will see over the next 4 to 8 years or 7 years how well we can do. And the power law exponents are stable over time for a decade. This shows the dollar and gold. And it shows, if you looked at age 6, what would you have measured for the power law exponent? And you would have been coming off of a bubble. Let's see, age 6 is beginning of 2015. The 2011 and 2013 bubbles have lifted it up towards almost 7 there, when it hasn't really locked in fully its power law behavior. But by age 7, it's starting to lock in, and age 8, it's locked in pretty nicely. And for both of them, they've been below 6 and, 5.4 now for gold, 5.7 roughly for Bitcoin, and very little fluctuation over the past decade. And the shaded bands are the standard error in the exponent for those. And you can see it gets tighter and tighter. So they're within 5% of each other. The standard errors continue to contract. The R squared has exceeded 0.9 since 2016. Now we're at 0.96 for the R squared on those. So this summarizes the exponents presently for the 10 power laws. They're all above 0.95 for R squared. You've got the 6 currencies on the left and the 4 commodities on the right. And you can see there's a very modest range. They're all within 6% of the exponent value for the US dollar. So the takeaway is the dominance of Bitcoin, regardless of what you measure it in. And this is in part because Bitcoin conquers both space and time. Gold conquered time for thousands of years now. Fiat got efficient at moving around in space, and to a lesser extent between national borders and between currencies. Bitcoin, very rapid, completely global, neutral. You move it across borders, and it doesn't have to go through all of those issues that you have in the Swift network and other networks where it takes maybe 3 days if you send a wire to another country. So time is indicated with that small graphic in the upper right, and space is indicated by the small graphic in the lower right, as it's going across currencies and national borders. And this is always our suggested reading. You can find at the scientificbitcoininstitute.org/research links to the paper and the preprint version, and then of course Giovanni's book. Okay, I'll end there.
Very good, very nice presentation. And these are also something that comes often into discussions about Bitcoin, power law, because many times people say, well, the denominator, it's important, and they don't realize exactly what we just showed, that it works with basically anything reasonable. In fact, even if you try to do it with other things like the Argentinian pesos, you can find a power law. It will be slightly different power law, but there is a power law even there. So it works for everything. And the main reason is because we are describing a universal phenomenon. We are saying Bitcoin has these scaling properties. And so anything else that can affect the price, like, for example, inflation, it's just a rounding number. Stephen made the case. Or even changes of the underlying asset. If gold managed to go 3 times, that actually is almost like it woke up, right? One of the reasons why it's so beautifully following the power law until recently is because it basically was flat relatively to the dollar. It didn't change much. But then actually it caught up. And the idea of gold is that it should be an edge against inflation over a long period of time. They say, and not by growing much more than inflation, but basically staying up to inflation, right? They say that if you buy a beautiful suit today, like a professional suit today, it costs more or less what it will have cost to buy one of these toga, like Roman togas. That didn't change much. I think certain things changed. Like one time I was actually doing this study, that is another interesting things to study, very fascinating. A chicken will have cost you so much more than now at the time of the Romans, because they didn't eat much meat. And meat was something for the rich. Most people eat basically kind of porridge, and some lentils maybe or something. But a chicken will definitely is much less expensive now. You can buy a chicken from a cooked chicken in the US for $10, right? One of these rotisserie chicken. people in the ancient times will have found amazing that you can do that because it costed many, many times more. But certain things that require human effort, like making a nice suit, they cost more or less the same. So over time, gold needs to actually be an edge against inflation if it is a good um, reserve of value. Um, and so in the last few years, it grew up, right? It grew also because geopolitics or whatever, by a factor of few. And people thought, whoa, look at this, gold is amazing. What are you talking about? Of two or three relatively to Bitcoin, they grew 100 million times in 16 years. So it's a rounding error. Even that is a rounding error. And it shows up with that deformation. Many people think, oh, it's breaking the power law. It cannot break the power law. A factor of three cannot break. It's going to look slightly different from fiat because of a power law is so clear with the dollar, because it's mostly showing how Bitcoin is scaling relatively to the underlying currency that is the world currency. People don't do much on a daily basis with gold. It's more like a store of value um, than something that is traded on a daily basis. And so, of course, there will be a small deformation that is due to the interchange of gold relatively to USD. But even that is not enough to challenge the power law. Gold will have to go up by factors of tens, if not hundreds, to actually start to deviate from, in a very strong way, from the power law. And it doesn't, and it cannot. You know what? It cannot. If gold is already on the order of tens of billions of trillions of dollars in terms of market cap, Bitcoin will have to go all the way to $1 million to be on the size of a market cap of gold. And all the earth wealth is on the order of a factor of 10 bigger, maybe 20, 30, right? So factor of 10. So gold at most can go up another factor of 10 up. And historically, that will be already amazing because even with this almost explosion in gold value, went up only a factor of three. It's not going to go up another factor of 10. It cannot. Also because you know what happened if that happened, because gold, differently from Bitcoin, is relatively, if you think you can hack Bitcoin, think about how easily you can hack gold by doing what? Things like I was told by when I was away from Italy, and I was talking with some lawyers about some issues, and they were telling me there were news of people digging in graves. We are trying to find, because one of the things that up in Italy, a lot of people have gold rings, right? Marital rings, wedding bands, and people were digging in the graves to take this gold. When gold starts to go to crazy prices, miners in Peru start to dig it from the ground, from crazy places that are cold and inaccessible in the mountains, because we are motivated enough to do it, and that crashes the price. You cannot do that with Bitcoin, because we have even if you start to mine Bitcoin, and the price starts to go up, and people start to be motivated in mining or whatever, there is the difficulty adjustment that takes care of that. So it's a system that auto-regulates itself. So yeah, gold cannot go a factor of 10 up. I'm pretty sure in the next 20 years it will not do that. Bitcoin can go
It would
up.
have to match all real estate if it
Yeah,
did that.
Bitcoin could do it. Bitcoin
Yeah.
has the potential of doing it, of going up 10 or maybe even 100 times. Then we will see. It depends how fast the economy grows. If AI creates another factor of 10 in economy, we don't know. But we're talking about the next 20 years. Bitcoin can do it. If there is anything can do it, Bitcoin can. So yeah. Anyway, I think we have one good question, and Kenny say hi. Hi back, Kenny. Kenny B. We have this question. Uh, you can give it a try. I will also give it a try.
Well, it's better than having one random source. And I've read, I can't recall which one. There's one wallet that has 7 random elements. But you can imagine there's electrical noise, there's thermal noise, there's vibration noise, there's cosmic ray noise, there's this shot noise, other sources. Shot noise is more like the electrical noise. So it's better than having one noise source, but it's still software, right, that has to measure that. And the noise is not itself completely random, it's pseudo random. It's probably any of those noise sources are less random than 99 dice. And right, because they're coming from some generative process.
And also sampling, right? We will have
Yes.
to digitize. That is
Yeah.
another thing that I didn't think about before. We will have to digitize
Yeah.
the noise, and
Yeah.
so also that reduces the space in somehow.
And so then you've got to feed it through software, which adds more attack vectors.
Yeah. And
So it's
again,
safer,
I,
but not
I
as
know it
safe.
sounds so crazy because many people think technology is a solution for everything, and I am the first one to tell you, but you know what? I go to work with a bicycle, and you know what? A more advanced technology like a car will do a worse job because and I can go through little streets where cars don't even go in Italy, or they are close to traffic because they are meant for pedestrians. With my bike, can go there. You see, low-level technology can solve a problem, but a high-level technology will not. I'll even check that is going to take me longer if I had a car. I don't have a car in Italy. I own in the US. If I had a car to go to work, it will take longer to go through the streets that allow the cars than with the bike. So this is an example of simple technology, a bicycle that can solve a problem that high-level technology cannot. It's still a technology, a nice one. I have a nice bike, but it's simple technology, and it does the job. It does it better than an advanced one. And parking, same thing. I can park my bike in front of my job. With a car, I will have to look everywhere, and it's not easy to find a place for parking in a modern city. So yeah, if this example doesn't convince you, so yes, strangely enough, a bunch of dice gives you more randomness. It's something you do once. If you find it nerdy, don't tell anybody. But you should probably don't tell anybody anyway, and just do it when nobody watches you. So, but why not? I don't get it. It's something that literally takes 10 minutes of your time. And we have a tool now. You can use our tool. If you're worried about it, say, but also that is code. Copy, paste the code, give it to ChatGPT, do it 3 different ways. ChatGPT and Claude or whatever, and say, do you see a problem with this? And they will tell you no, because it's very straightforward code. And then now you say, I could do it also with the code of the other. Yeah, I bet I can tell you, taking some internal noise and transforming it into randomness is not that straightforward. It takes many steps more than the relatively simple algorithm to go from dice to this seed phrase. It's also is an established algorithm. It's maybe it's not completely trivial, but it's an established algorithm that is published and audited, and so the AI will know that we are not following the right procedure. Right? Say, I have to trust AI. And at a certain point, you have to try. And I'm telling you, I will post it anyway on the website just in case. There are actually completely manual way of doing it. There are tables of words that you could download double check. Again, you will have to trust that the place where you downloaded is okay. But there is a point where you do so many things that if you, in particular, if you understand it, right, it's just a bunch of words. We are in a certain order. You pick them randomly through a random process that you control. There are some checks that you can double check. Once you understand the process, then you realize, yeah, I'm doing correctly, because you are in control. And the most important thing, the most fundamental act, that is this initial randomness that you created, nobody can recreate. And it's simple, but it works. So, I'm not telling you, I'm not judging you, I'm not condemning you if you do something else, but it's nice to know that there is this possibility and it's available, and it's relatively simple. Okay, guys, this was a good show. I think we covered a lot of interesting topics. You can always DM us. We are available, to be of assistance. If you have any questions or whatever, both I and Stephen can be reached on X. We have on the website, there is also contact us. If you want to contact the Institute, we have info at Scientific Bitcoin Institute. We read your emails. If you want to contact us, ask some questions, let us know. All right, guys. See you next week. Oh, I needed to tell you, because this is what Stephen was saying. We're going to have another show. I know this show is a little bit more technical. I think Stephen covered a relatively simple topic today. It was a little bit more technical than what many other show covers, but simpler than some of the things we do cover. There is a reason why we do that. Is basically recording our exploration, scientific exploration of Bitcoin, and we want to share this exploration with you. And that is the purpose of the show. I know that sometimes it's difficult to follow all the things we talk about, but the entire board, so it will be also an opportunity to meet the board of the Institute. Is several of us, and we have different expertise, different life experiences, and we are going to have a show on Thursday, more or less around this time. It will be called something like the Scientific Bitcoin Institute weekly show, something like that, maybe something more punchy, but it will basically show that it's not just me and Stephen. We have several people that are joining this effort. We want to bring rationality, science, knowledge to Bitcoin and sharing our life experience with you. And mostly we will talk about the price. I know it's something that many people are interested in. We are going to look at charts. There is Pios. He's both a mathematician because he got a PhD in mathematics, but also has extensive experience in markets. He's actually, if not him, his boss is featured in The Big Short, that famous movie about the financial crisis in 2008. So he has a very interesting life experience that they can share with us. And other people, in the board that have a different expertise. And so we will make a group and talk about different situations like this, the price or news that, that happen in the Bitcoin world. It will be more kind of accessible show, and we are going to do it at the same time, but on Thursday. Okay, guys, see you then.